Okay, this is the last section of Chapter 8, the last thing we're going to be working on, which is solving rational equations and inequalities. We're actually going to split this section into two parts. Today we're going to be talking about just the basic solving of those, and then in the second video we will talk about how to solve different kinds of word problems that involve distances and rates and work and mixtures using rational equations and inequalities. So those are our two goals for today, solving rational equations and solving rational inequalities. All right, the vocabulary you need to be on the lookout for is rational equation, weighted average, which we'll actually see in the next video, and rational inequality. So when I'm solving rational equations, first of all, a rational equation is an equation that has one or more rational expressions. Remember, rational expressions are the quotients of polynomials. These equations are usually easier to solve if I eliminate the fractions. So that's going to be my goal, is to eliminate the fractions. And to do that, I do it just like I would with numbers. I multiply each side by the least common denominator. So for example, if I have 1/2 plus 2/4 x equals 1/6, let's say, just making this up, what is the least common denominator? Well, it's 12. 2 is a factor of 12, 4 is a factor of 12, and 6 is a factor of 12. So I would need to multiply the left side of my equation by 12/1, and the right side of my equation by 12/1. Obviously, I distribute on this side. 12 times 1/2 would be 6. 12 times 2/4 is 24/4, which is also 6x. Equals 1/6 times 12 is 2. So when I multiply both sides by the least common denominator, basically what I do is I get rid of the fractions. This is different than simplifying rational expressions. Remember back in section 2, we had something like 2 plus x over 2 minus 5 times 2x plus 4. There was no equal sign, and so when I simplified this, I had to say, okay, if I factor, this is 2 times x plus 2, so I'm missing a 2 over here, and I had to multiply this fraction by 2/2. I had to multiply by 1, basically, so that I didn't change the value, because there's no equal sign. This was an expression. So this would become 4 over 2x plus 4 minus 5 over 2x plus 4, which gave me -1 over 2x plus 4, and I could combine them into one fraction. That is different than what we're doing with equations, so make sure you keep separate simplifying expressions where I have to multiply by 1 and get a common denominator, to solving equations where I multiply both sides by the common denominator, but since it's an equation, I don't have to multiply by 1. In this one, I multiplied both sides by 12, and I get a new equation with no fractions that's still the same equivalency and solve like normal. So let's look at this first example. 5/24 plus 2/3 minus x equals 1/4. So the least common denominator is the least common multiple of the denominator, just like we did back in section 2. Since 4 is a factor of 24 already, my LCD is just 24 times the quantity of 3 minus x. So here's my original equation, and then what I'm going to do is I'm going to multiply each side by my least common denominator. Right, and since this side has two terms, I have to distribute my least common denominator to both terms. So that's what they're showing you here. 24 times 3 minus x times 5/24. Notice the 24's divide out to 1. Then here's my LCD again times the second term, the 3 minus x's, divide out to 1 because those are factors. And then here's my LCD again on this side. The 4 and the 24 divide out. 4 goes to 1, and 24 is 6. And so now I just have to simplify. So on this side, I'm left with 3 minus x times 5. So that's 15 minus 5x. That's where they got this part. Right here, I'm left with 24 times 2. That's where they got the 48. And then on this side, I'm left with 1 times 3 minus x times 6. So I'd take my 6 times 3. 6 times -x, that's where I get 18 minus 6x. And from there, it's just basic solving, right? 15 plus 48 is 63. And when I add 6x to both sides and subtract 63 from both sides, I get x equals -45. Now, anytime I have a rational equation, just like a logarithmic equation, I have to check in the original one before I got rid of the fractions. So I'm going to see, okay, does negative 45 work in this situation? So I plug it into the original x. Remember, when I'm checking, I don't move things side to side. So here, I'm just simplifying. I get 2 over 48, which reduces to 1 over 24. When I add those together, I get 6 over 24 on this side. And 6 over 24 does reduce to 1/4, so that solution is correct. So the solution is negative 45. So here's one for you to try that is very similar. All right, the answer to this one is B, and I'm going to show you the work. So notice here my least common denominator is 2 times the quantity x minus 1. So in this first step here, I'm showing you that I'm multiplying each term times 2 times x minus 1. In the first term, the 2's divide out to 1, so I'm left with 5x minus 5 when I distribute. In the second term, the x minus 1's divide out, so I'm left with 2 times 3, which is 6. And on the right-hand side, the 2's divide out to 1, and I'm left with just 1 times x minus 1. And from there, I just solve regularly to get x equals negative 1/2. Now make sure that you also check. I'm not going to take the time to show you the check for this right now, but that will be a requirement for you to do. All right, let's look at one that's a little bit more complicated, right? So here in my denominators, I have p plus 1, that's one factor, and p minus 1. So that means that my least common denominator is going to be p plus 1 times p minus 1. So again, I need to take every term, every part of my original equation times that least common denominator. So here they're showing you p squared minus p minus 5 all over p plus 1. When I multiply that by p plus 1 times p minus 1, the p plus 1's divide out. Same on the right-hand side. In this first term, my p minus 1's divide out. And in the last one, since there's no fractions, that's just going to be multiplied all together. So this is going to require a lot of distributing and a lot of precision with the way you do your math. Okay, so this is what it looks like after I've divided out my common factors. Notice when I did that, when I multiplied both sides by the least common denominator, my fractions went away. Okay, so basically what we did to get to the next step is a lot of distributing. P times p squared is p cubed minus p squared minus 5p minus p squared plus p plus 5. Be super, super careful with your negatives and positives here. Then the same thing on this side, I FOILed and got p cubed plus p squared minus 7p minus 7. And then remember here, p plus 1 times p minus 1 is p squared minus 1. And then when I take the p times that, I get p cubed minus p. So I have lots of terms here. And they're showing you that we just simplified to get to the next step. So negative p squared minus p squared, for example, on this side, gave me negative 2p squared. Negative 5p plus p is negative 4p. On the right-hand side, p cubed plus p cubed is 2p cubed. Then I just have a p squared. Negative 7p minus p is negative 8p minus 7. And I'm moving everything to one side and getting it equal to 0 to see if I'll be able to solve. So here I have a cubic function, a cubic equation, and basically what we're going to do is factor. Okay, so if we think about this process here, we're going to factor by grouping. And factoring by grouping is something you should already know how to do. Remember, I group the first two terms together and factor out their GCF. Group the second two terms together and factor out their GCF. These two factors should match, so that's now the common factor. And I'm left with p squared minus 4, which of course is the difference of squares, p minus 2, p plus 2, and then stays with my p plus 3. So that's where they got the factoring over here. I set each of those factors equal to 0, right? So that ends up giving me p equals negative 3, or p equals negative 2, or p equals 2. And we have to check all of those. So for p equals negative 3, I plug that in everywhere, and I check to see if it gives me something equal. Feel free to pause if you need to look at the simplifying a little bit more, but basically what happens is it does check out. I end up with negative 7/2 equals negative 7/2. It's going to require good fraction skills from everybody. Now I'm going to try p equals negative 2. When I plug in negative 2 for all of the p's in the original equation, I end up with 4 plus 2 minus 5 over negative 1 on this side, and on the other side I end up with 1 minus 2. And so that one also works. So far I have 2 solutions. Now I'm going to try positive 2. Put the positive 2 in for all of the p's. Again, this is something you would have to do on a problem. And this time I end up with something that also works. So in this particular case, all 3 of my options are true. All 3 of them work. I have 3 solutions for this equation. Okay, here is one for you to try. In this case, I end up with negative 2, x equals negative 2. Okay, here's the work as well as the check that I showed you over here. This one was not as long as the previous example, so I'm sure you enjoyed that. My least common denominator was x plus 4 times x minus 2. Multiplied every term by that. I ended up with a quadratic equation to solve, but both of my factors were the same. Remember, that's called a double root. So I end up with x equals negative 2, and when I check it, it does work out. All right, last but not least for the first part of this section is solving rational inequalities. So there are 4 steps here. Step 1 is to find my excluded values. So what x values make my denominator 0? Then I solve the related equation, so I turn it into an equation and basically do what we just did, find the solutions. And then the excluded values and the solutions of the equation, I use those to divide a number line into intervals, and then I have to test a value in each different interval to figure out which intervals are true and false. This is kind of like what we've done before. So let's look at this first example. Here I have a pretty easy way to find excluded values. What would make my denominator equal to 0? Well, anything where 3k would equal 0 or 9k would equal 0, meaning that 0, k equals 0, would be my excluded value. Now I'm going to solve the related equation. So I'm just going to replace the less than with an equal sign for a minute to find the solutions. My least common denominator here would be 9k, so I'm going to multiply each side by that, and I need to multiply each term by that. So when I do 9k times 1 over 3k, I end up with 3. And then I do 9k times 2 over 9k. And here they already showed you the 2/3 times 9k. So here 9k and 3k divide out, and I'm left with 3. Here the 9k's divide out, and it's just plus 2. And over here the 3 and the 9 divide out to 3. 2 times 3 is 6k. So I have 5 equals 6k, which means that k is 5/6 when I divide each side by 6. So now I have my excluded value of 0 and my solution of 5/6. So what I do is I just take a number line, I draw a quick number line on my paper, and I separate by where my excluded values are. So I draw a line here, and here's the solution of my related equation. This is where the 5/6 is. So this divides my number line into 3 parts, and I have to test a number in each part to see which regions or which intervals make my inequality, remember we're solving an inequality, so I'm plugging into the original, true. So I'm going to start with testing -1, because -1 is an easy one to test on this side of 0. And when I plug it in, I end up with -1/3 minus 2/9, and I'm wondering, is that less than 2/3? And it is, because a negative number is always less than a positive number. So less than 0, that works. Now I need to test something between 0 and 5/6. So here we're going to try 1/3, because that multiplies nice with 3 and 9. So you want to try to pick numbers that are going to make your math easy. So I have 1 plus 2/3. Is that less than 2/3? No. 1 and 2/3 or 5/3 is not less than 2/3. So that middle section is not a solution. Then last I test something larger than 5/6. 1 is the easiest one to try. 1/3 plus 2/9 turns out is 5/9, which is less than 2/3, because remember 2/3 is, oops, not 4/9, sorry, 6/9. So 5/9 is less than 6/9, so that is true. That means that my solution is less than 0 or greater than 5/6. So here below 0 I had things that were true, not true between 0 and 5/6, true greater than 5/6. All right, last one for this video, you try this one. Your answer here should have been C. And here is the work for that. Your excluded value is 0, And then your solution is 4. Divide your number line. I showed you 2 of the points I tested. I didn't show you one greater than 4, but this ends up being your solution, less than 0 or greater